But after 10 million years on top, the beast disappears from the fossil record for reasons no one yet understands. While the horseshoe crab is a distant relative, the first killer jaw would have no descendants.
Evolution is, in many instances, a battleground. I mean, let's face it, life is intense out there. Species have to constantly keep changing in order to prevent themselves from going extinct. It becomes a matter of life and death, really, whether or not individuals can adapt in time to this constantly changing environment.
Jaws would evolve again in a huge way. In a completely new line of animals, fish. It is 430 million years ago, and fish are the first animals to have a backbone, the first vertebrates. They are the ancestors of all vertebrates, including us, but they have no jaws, only openings too primitive to be called mouths. They feed by literally swimming into their food, or by stirring up mud, counting and finding suspended particles for sustenance. But in one group of fish after another, a change occurs. Primitive fish have bony arches that hold up their gills. The fossil record suggests that over time, natural selection favored fish whose arches were set forward until they were able to grasp the food trying to wriggle away. The bottom arch swiveled. The top arch provided stability. It was a structural change that enabled survival and, with much variation, has persisted to this day in thousands of species, including our own. An extinct group of fish called placoderms were the first to develop jaws. This predatory edge made one of them the T-Rex of the seas. The exact nature of the beast's jaws has been a mystery until now.
I'm standing next to Dunkleosteus torelli. It got up to 20 feet long and probably weighed a ton or more, and it was highly predatory.
Mark Westneat, zoologist at the Field Museum in Chicago, has been working to unravel the mysteries of Dunkleosteus. Why did its jaws grow so large? How did its strange toothless jaw operate?
Dunkleosteus and other placoderms don't have teeth. They have a large bony lower jaw that has an enamel covering along the rim, and it is quite sharp at the tip. It's like a meat cleaver.
Westneat believes the jaws grew so large and the blades so sharp to crush the hard outer shells of invertebrates that filled the oceans at this time.
We think that it had a scissor-like action where the two plates would meet one another and slide past one another, much like a pair of scissors.
Westneat devised an ingenious plan combining several methods to decode the biocomanics of Dunk's bite. First, he used forensic reconstruction techniques to model Dunk's jaw and neck muscles, took measurements and calculated their power. This led Westneat and his team to a startling discovery. Dunk had muscles pulling both sides of its jaw up and back. Essentially, a perfect example of the modern engineering structure, the four-bar linkage, used to multiply force in everything from pruning shears to steam locomotive drivetrains. This two-muscle opening system rapidly opened the mouth hugely wide and slammed it shut just as fast. Intrigued, Westneat's team built a 1/3 scale model of the jaw to observe the bite in action.
We simulate the muscle properties, the speed and force of contraction of these muscles using properties from modern-day shark muscle. Many vertebrate muscles have very similar muscle properties, and so we think that's a reasonably accurate reconstruction of what was powering the Dunkleosteus skull.
The final computer calculations stunned the team. Dunk's bite took just 70 milliseconds, creating an inrush of water and a bite force of 1,300 pounds. Dunk's bite fell like a guillotine, the most ferocious of any sea animal ever. The prey wouldn't stand a chance. But, like Anomalocaris before, Dunk went extinct, along with the scissor blade jaw. Its disappearance, another scientific mystery.
Extinction is a very powerful creative force in evolution. Extinction will almost inevitably open up new niches that can then be colonized by other species.
Dunk's niche as top predator would rapidly be filled by a creature that would succeed with a new kind of jaw, one that still hunts to this day: sharks.